11 sequences in series. We've got this sequence generated by 4 to the n plus 1 on top and 5 to the n on the bottom. Does it converge or diverge? So in other words, as n gets bigger and bigger and bigger, do the values level off or diverge? Has two possibilities. One is as you have n equals 1 and n equals 2 and n equals 3, it could be that the values just keep getting bigger and bigger and bigger, and so they're going to infinity. That is called diverge. There's another possibility, much like sine or cosine, that the values don't go to infinity, but they just keep going up and down and up and down, and they never settle on one answer. So these are the two cases for diverge. And then converge would mean that as you follow the values out, they just level off at some particular height. So that's converge. And then whatever that height is, that's called the limit that it's converging to. So let's see, for this one thing you could do is plug in a bunch of numbers. A1 would mean this is going to be 4 squared, and this would be 5, so 4 squared, 16 over 5. And then A2 would mean plug in 2, so this is going to be 4 to the 3, which is 64, and then over 25. So you could just do that with or without a calculator for days on end, or however long you want. You could also use a calculator. It would need to be on, I would suggest to put it on regular function mode and go y equals, and now it's going to be a function of x. So it's going to be 4 is raised to the x plus 1 divided by 5 raised to the x. And then you could make your own, or have the calculator make your table of values for you. So you first go to second table setup. So start at 1, go in increments of 1, and then second, make the table. So then you could follow these. So the first one was 3.2, etc., etc. And then you'll notice that the values are getting smaller and smaller and smaller until they practically disappear. Alright, so it seems that the sequence is going to converge to 0. You could also look at the graph, have this go out very far, so 0 to a really big number like 35. Now I believe the answer is 0, so what I'm going to do is have this be very close to 0. And then take a look at the graph. So at first you don't see it, it's so tall, but then it drops down to practically nothing. Now keep in mind with a sequence we're talking about individual dots, not the continuous function. But basically by using the calculator what I've done is the dots are in there for when x equals 1, 2, 3, etc. And then the calculator has just traced over those dots. But still that tells us what the dots did. So it seems that the answer is 0. Now can we actually prove it? Well, let's see. We could take the limit as n goes to infinity of 4 to the n plus 1 over 5 to the n. And since n is going to infinity, 5 to infinity is infinity, 4 to infinity is infinity. That means you're allowed to use L'Hopital's rule. So if we do L'Hopital's rule, it's going to be the limit as n goes to infinity, and then the derivative on the top. So the derivative of an exponential function is itself. Because the base is not e, you then need to take natural log of that number. The same over here, it's going to be 5 to the n, and then times the natural log of 5. And we still have n going to infinity. Now, at this point, I look at this and say, well, what's the difference between that and that? And it's just these little constants over here that aren't going to change the answer. So that means that L'Hopital's rule didn't take something that was more complicated and make it simpler. In this case, it's pretty much the same thing. So that's not really going anywhere. Stop. What else could we do? Well, if you just blur your eyes for a second and don't look at the exponents, this is screaming out 4/5, 4/5. So if you have a number, 12, I'll just randomly choose a 12. And you take 4/5 of it, it's going to make it smaller. And if you take 4/5 of it repeatedly, because these both have exponents, so it means do that repeatedly, then it's going to get smaller and smaller and smaller until it disappears. So could we do something with 4/5? So an is equal to, well, this has a 4 to the n and it has a 4 to the 1. So I could rewrite that as 4 to the n and 4 to the 1. And then I could put the single 4 in front, and then this is 4/5 to the n. And then, like I said, you take 4/5 of something repeatedly, or if you were to look at the function y is equal to 4 and then 4/5 raised to the x, it's the same thing, it goes down to 0. So when a sequence is in this form, this is called a geometric sequence. And the number that's in here that's being raised to the exponent is called r. And a geometric sequence will converge if the r is less than 1. It's actually possible that the r can be negative, so technically we say if the absolute value of it is less than 1. And so with this one we say since r equals 4/5 is less than 1, it converges.